The previous video, we defined the null space and talked about its dimension and basis. Didn't quite do an example. Most of the work is really coming up with this reduced row echelon form in the first place. That's where the tedious work happens. In this case, it's sitting here for us for this example. We had this theorem called the rank nullity theorem. It says the rank of A plus the dimension of the null space is n, the number of columns of A, or that the dimension of the null space is n minus the rank of A. That is also the number of free variables. In that case you just saw there, we have 5 by 7, so n is 7. We have 3 pivots. N minus 3 is 4. We have 4 free variables, and the dimension of the null space is 4. And we come up with the basis by using the 1-0 trick. We have to really convert these things to what they mean in scalar equations. You'll get an equation for each of the pivot variables in terms of the non-pivot variables. That is, if you use full Gauss-Jordan elimination to come up with this, so that you have a matrix in reduced row echelon form, which is the preferred way to do it because it saves you sort of back end algebra if you try to do it with just normal row echelon form. So our method will be full Gauss-Jordan elimination to start with. So let me do an example. First, we'll state something. We call A full rank if its rank equals that n. That means that the dimension of its null space is 0. And that means the only solution to this homogeneous equation is x equals the trivial solution, 0. We'll use that fact a little bit later. So here's our method for finding the dimension and basis for the null space. We use elimination, in fact, use Gauss-Jordan elimination. The dimension is n minus the number of pivots, which is the rank of A. Number of pivots is the same as the number of non-zero rows, which is the same as the rank. And then a basis is found by using the 1-0 trick with free variables, i.e. the non-pivot variables. So let's say this is our A. We start there, we do row ups, we get it into reduced row echelon form. 2 pivots, row of all zeros at the bottom, both pivots are 1, the pivot columns are zeros except for the pivots themselves. So by this step, we know the rank of A is 2. This guy has 4 columns, so the dimension of the null space is going to be 4 minus 2, or 2. We knew that at this step, once we got it to row echelon form at all. And now we know x1 and x2, these are the 2 pivot columns. They correspond to x1 and x2, so that these other 2 columns correspond to the free variables, x3 and x4. So write the equations for the pivot variables in terms of the non-pivot variables. x1 equals x3 plus 2x4. x2 equals minus 2x3 minus 3x4. Do the 1-0 trick. First I'll set x3 to 1 and x4 to 0, so that x3 equals 1. And when x3 equals 1, x2 equals minus 2. There's 1. Here's the other one. When x3 equals 0 and x4 equals 0 and 1. So x1 will be 2, x3 will be minus 2. There's a basis for that null space. Should I bring up this fact? Is a square matrix invertible? I'll say this for you.